Welcome back to our channel. You're in the right place for the most exciting updates from the cosmos. Today we've got some thrilling news about a mesmerizing sky phenomenon, the northern and southern lights, or scientifically known as aurora borealis and aurora australis. Lately, more people around the world have been able to see these stunning lights with the naked eye. So, what's behind this spectacular display? It all started with a powerful solar storm that significantly affected Earth's magnetic field. The sun hits its peak activity in an 11-year cycle, and we're at that peak right now. This means more explosive solar particles are being sent our way. Under the right conditions, these particles create beautiful auroras and sometimes geomagnetic storms that can disrupt our power grids and satellites. But what's the science behind these incredible lights? Normally, the northern and southern lights are confined to very high or very low latitudes. High-energy particles from the sun are directed toward Earth by the sun's magnetic field. When they reach Earth, they get caught up in Earth's magnetic field through a process called reconnection. These super-fast, hot particles travel along the magnetic field lines until they collide with neutral atmospheric particles like oxygen, hydrogen, or nitrogen, heating up the local environment. These atmospheric particles release energy as visible light. Depending on which element is heated, you'll see different colors in the auroras. Blues and purples come from nitrogen, while greens and reds come from oxygen. This process happens all the time, but during strong solar events, we can see auroras much farther from the poles. Now, what's happening in the northern hemisphere that allows us to see auroras much farther south? You might remember from school, scattering iron filings on paper over a magnet to see the magnetic field lines. Earth's magnetic field is similar, but it can be compressed and released depending on the sun's activity. Think of it like pressing two half-inflated balloons together. When the sun is very active, it compresses our magnetic field, pushing the auroras closer to the equator. But this strong solar activity can also cause some serious problems. Moving magnetic fields can generate currents in anything that conducts electricity. For modern infrastructure, the biggest currents are generated in power lines, train tracks, and pipelines. Researchers track the strength of these movements with a measure called the Disturbed Storm Time Index. The geomagnetic storms on May 10th and 11 were exceptionally strong. Such strong storms can induce dangerous electrical currents. Power lines are at the greatest risk, but have protections thanks to measures taken after the 1989 geomagnetic storm that melted a power transformer in Quebec, Canada, causing hours of power outages. Metallic pipelines are also at risk as they can corrode when electrical currents pass through them, causing long-term damage that's hard to detect. Ground currents are problematic, but they're even more challenging in space. Satellites have limited grounding, and an electrical surge can destroy instruments and communications. When a satellite loses communication like this, it's called a zombie satellite, often leading to a total loss, resulting in a significant financial hit. Changes in Earth's magnetic field can also affect GPS systems. We can't see this change, but it can seriously affect location accuracy because it depends on the time taken between your device and a satellite. Increased electron density causes signal bending, making it take longer to reach your device. Auroras aren't limited to Earth. Many planets have them, and they can tell us a lot about the magnetic fields on those celestial bodies. Using devices like the Planetarella, we can simulate auroras here on Earth to study these magnificent light shows and the magnetic fields that create them. So next time you look up and see those beautiful lights, remember all the science and excitement behind them. Keep watching for more amazing space updates, and don't forget to like, comment, and subscribe.